Hi, Mr. Barre here. This is the unit conversion with precision homework assignment. I'm going to do a couple problems with you. Read the instructions so that you're going to meet my expectations on this assignment. If there are any parents watching that are engineers, just go with it, man. I recognize this one. I recognize there's some room for improvement in this lesson, but for the general population, this is good enough. Remember, when we're actually measuring things, we can't get super precise. It depends on our measuring instrument that we're using. Am I using a ruler? Am I using calipers? Am I using some kind of a laser thing? So the instrument itself only has so many decimal places or significant figures. And now when I take two measurements and I start multiplying them together, my calculator gives me this new number that might have 10 decimal places. Does that suddenly mean that my new value is more precise than the measuring instruments that I was using to get that value? And the answer is no. My calculation can't actually make my answer more precise. So we have to think about our measuring instruments and the initial precision and use that to drive out our final answer and the precision of our final answer. Okay. So it's based on sig figs, which we just did. I look at this, 3 miles into meters. I'm going to do the conversion, and I'm going to just use Google for it, okay? So that's fine. This isn't a lesson on conversion, but actually I'm not going to use Google. I'll just do it with this. So 3 miles into meters. I want to use Google, though. Okay, 3 miles into meters. I'm looking at my conversion thing. Okay. So 3 miles into meters, that's going to be 3, I'm trying to do the math here. I have it as 4,800. That sounds right. Okay, so 3 miles is 4,830 meters. The thing is, I'm assuming that this is only good to one significant figure, which means this answer is only good to one significant figure, which means I'm going to round this to 5,000. And I know it's ambiguous, but we're still going to go with it. That's the idea. Which is actually right. You know, 3 miles is 5K. When you run a 5K, you're running 3 miles. Okay, 3.5 yards into inches. Let's do the conversion first. So 3.5 times 3.5 yards. So 3.5 times 3 turns into feet times 12. So this is 126 inches. But this was only 2 significant figures, so this can only be 2 significant figures. So I'm going to round this to 130 inches. 32 feet per second squared into meters per second. Excuse me, 32 feet per second into meters per second. So 32 feet and meters, feet. 32 feet is converting it into meters. So 32 feet per second is 9.753124 meters per second. But this is only good to 2 sig, so I have to take this to 2 sig, so that's going to turn it into 9.8. Which, if you've taken a physics class, you're going to recognize this is actually 32 feet per second squared. This is the acceleration of gravity in English units. 9.8 meters per second squared is what we use for the acceleration of gravity in metric units or SI units. So these numbers, actually twice now, I'm seeing that these numbers are actually making sense and working for me. Find the area in square meters of a 13-foot by 14-foot floor. Let's do the conversion first. So 13, converting that into, okay, so I'm turning it into meters. Where is it? 13 divided by 3.2 81. So this is 3.962. That's meters. So 13 feet is that many meters. Divided by... And this is 4.26699. So this is 13 feet is 3.962 meters. 14 feet is 4.26699 meters. Multiply them together. And I get something like this. I get 16.905, blah, 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 blah. Look, how am I getting more precise? This was 13 feet by 14 feet. I don't know. Was I off by an inch or two? I don't know. I know this is 2 sig figs. This is 2 sig figs. This answer is only good to 2 sig figs, or 17. Can't see it, but my answer is 17 on that. So that's the idea. Basically, look at how many significant figures or significant digits you have in the original numbers, and your answer cannot have more significant figures than the originals. 1 sig fig, 1 sig fig. 2 sig figs, 2 sig figs. 2 sig figs, 2 sig figs. 2, 2, 2. That's the game. Thanks for watching. I know it's a little bit weird. You know, this stuff probably messed with my head even when I was in college. In engineering, significant digits, significant figures, unit conversions, it's a big deal. And think about high-tech stuff, building aircraft and automobiles and things where you've got to be really, really accurate and really, really precise. When I worked for Boeing, we would be building parts in different areas, in different parts of the country, and everything had to come together and fit perfectly. And so they had to be right on with their measurements and with their tolerances, and this stuff is relevant. This is real life. Believe it or not, this stuff affects your life in the things you use. Your cell phone, the guys designing the parts and pieces for your cell phone were using this type of logic and math. It's real. Thanks for watching. Bye.